consists of two pairs of terminals A network consists of two pairs of terminals where one pair of terminals can be designated. When one pair of terminal can be designated as input, the other pair being output is called two-port network. A network consists of two pairs of terminal where one pair of terminal can be designated as input and other pair as output is called two-port network. Okay, so let us consider wait. Is it visible? No.
No, ma'am.
No, ma'am.
Wait. Is it okay? Is it okay?
Yes, ma'am.
Okay. Let us consider a network as two-port network as shown in figure. So this is, say, for example, two-port network. So what is two-port network? What was the first line you have already written? Two-port network. The network having what?
Two pairs of terminals.
Two pairs of terminals. So this is one pair. Okay? This is the second pair. So it is a two-port network. So the first pair, this is current I1 entering to the input port, current I2 output port, and V1 is the voltage with the input port, and V2 is the voltage with the output port. Okay, so this is the two-port network. That means what? V1 is the input voltage applied. When it is applied, the current I1 is flowing through the network. So the network having two pairs of terminals is called two-port network. Okay, so in vector notation, this can be expressed like this: V, Z, I. What is Z? Z is the impedance of the network. Z is the impedance of the network. So it is in the matrix form. So in matrix form, we can write this in matrix form. This can be written like this: V1 by V2 is equal to Z11, Z12, Z22, Z21, Okay. So this is the matrix representation of the two-port network. So this is the relation between output and input, between voltage and current. Okay. This is in the matrix form. So what will be the size of this Z? Z 2 by 2, two-port network. Okay. So this matrix is known as impedance matrix. This as a whole, Z11, Z2, these are all the parameters of the impedance matrix, and this is known as the impedance matrix. So output voltage, this is the voltage, and this is the current. That the input terminal current, output terminal current, input voltage and output voltage can be related with the impedance matrix in terms of impedance matrix. So this is the expression for two-port network. So what is two-port network? The network having two pairs of terminal, that is the two-port network. What are those terminals? P1, I1 as an input, P2, I2 as an output. So in matrix notation, this can be represented like this. P1, P2, Z11, Z12, Z22, Z21, I1 and I2. Okay. Again, we can write V1 is equal to yes or no?
Yes, mom.
Is it correct? See. By matrix multiplication, we can find out this. From this, we can derive this. Yes or no? Is it okay?
Yes, ma'am.
So, this two-port network can be represented in matrix form, and from the matrix form, we can derive this expression. Now, we have to find out Z11, Z22, and again Z12, Z21. These are the circuit parameters. And these parameters are known as the impedance matrix. So in every problem for this, to solve the problem with two-port network, every time you have to find out this Z11, Z12 by putting some condition. So what are the condition? First condition, when I2 is equal to 0. When I2 is equal to 0, what will happen? Z11 is equal to V1 by I1. By putting that condition, what is that? I2 is equal to 0. Yes? Again, Z21, how can we find Z21? By putting when I2 is equal to 0. So Z11 and Z21 can be obtained by putting one condition. What is that? Output current 0. Okay. The next condition, when I1 0. That case, we can find what is that? Z
I2, 1, 2.
1 2 equal to what? V 1 by I2 when I1 is equal to 0. You put this condition here, you will get this. From these two equations, by putting these two conditions, we can find out Z11, Z21, Z2. 1, 2, Z22, last one, last parameter. What is that? V2 by I2 when the condition I1 is equal to 0. So what is Z11, Z22? This is known as what?
Circuit parameters.
Circuit parameter, impedance parameters. Impedance. There are different types of parameters in the circuit. These are the impedance parameters. We have to find out admittance parameter also in case of two-port network. So this, since it is Z is the impedance. So this is known as impedance parameter. Okay. So first, for any problem, what to do? By applying KVL, you can write down these two equations. Yes or no? For any network, we can write down these two equations. After writing these two equations, by putting these two conditions, you can find out Z parameter. So these parameters are known as impedance parameters or Z parameters. So find out Z parameters. Suppose this is the problem. Network is given to you. You have to find out Z parameters. To find out Z parameter, you have to write down the equation. This is V1 equal to what? V2 equal to what? In terms of Z. And this Z1 and Z, write down, Z11 and Z22 are called output driving point impedance. Write down. Z11, Z22 are called input and output driving point impedance. This is input driving point impedance. This is output driving point impedance. Driving point impedance. But as a whole, impedance. Okay. Z12 and Z21 called forward transfer impedance. Forward transfer impedance. So what is this? This is called what?
Input and output.
Yes. Z11 and Z22. It's called what?
Input and output driving point impedance.
Input and output. This is the input driving point impedance. This is the output driving point impedance. And this is what? Forward transfer impedance. This is also forward transfer impedance. As a whole, this is what? This is the Z parameters. Z parameters. Okay. Now, equivalent circuit of Z parameters. Equivalent circuit of Z parameters. So, this is the equivalent circuit of the Z parameters. We have same input, output. Input current, what is that? I1. And this is the output current, what is that? This is I2. Okay. And this is the equivalent. Why equivalent? Because this I2 and this one, Z12, I1 plus minus plus minus. Why this is called equivalent circuit? From this circuit, we can derive this expression. This is Z11, this is Z22. Okay, so Z11, I1 plus Z12, I2. Left hand side. Similarly, for right hand side also, what is that? Z22, I2 plus Z21, 21, it should be 21, 21, I1. So that is already written here. See, this is the equation. Already written. So this equation, from this equation we can draw this equivalent circuit. So draw the equivalent circuit, you have to draw the equivalent circuit like this. Not this way. This is the two-port network. Draw the equivalent circuit. This is the way to draw the equivalent circuit, such that we can derive the expression for V1 and V2 from this circuit. See, any doubt, any question, you can ask me.
Ma'am, more than two impedances hole matrix to change হয়ে যাব?
More than two impedances? No. Always
two-port
2 by 2. Always 2 by 2. You have to take the equivalent value. So that is the objective of this. So you have different types of problems, network. So you can simplify the network such a way that you can find out Z11, Z22, Z12, Z2. Just 2 by 2 matrix, always. Okay. See, take the small problem. Say, okay. So this is the problem. Z1. See. So this is the problem. For the circuit given in the figure, find Z parameters. So what to do for this? Z1, Z2, Z3, okay? And this one given as I1, this is as I2, V1, V2. So to find out Z1 is not equal to Z11. So first step, what to do? কি করিম কোয়া? Try to write down the expression for V1. So what is V1? I1, Z1. Applying Kirchhoff voltage law plus Z3, I1 plus I2. I1. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. So you can apply Kirchhoff voltage law. Okay. Then next V2. Tell me, what will be the expression for V2?
I2 Z2.
I2 Z2, okay, plus Z3, what is that again? I1, both current are in downward direction, so I1 plus I2. That is simple Kirchhoff voltage law. So for every circuit, try to write down the expression for V1 and V2 in terms of input current and output current. So this is the expression, these two expressions related to this particular figure. So after writing these two equations, we can find out Z11, Z12, how? See, okay. From this, again further you can simplify it. like this in terms of I1, Z1 plus Z3. Yes or no? Simplify?
Yes, ma'am.
Okay. So this can be again simplified. I2, I1, Z3. Okay. I2, Z2 plus Z3. This part is little bit complicated, mathematical. So try to understand what to do, what is the procedure. First step after give this problem, for this problem, first step, what to do. You have tried to write down the KVL equation. In terms of what? In terms of input voltage, one equation. In terms of output voltage, second equation. And after that, you simplify these two equations. So in this case, what is your Z11? Can you tell me? This is your Z11. Yes or no?
Yes, ma'am.
This is what? Z1,
One, two.
2. Okay. This is what? Z21, right? And this is your Z22. Okay. So you can write Z parameters. You are asked to find out Z parameters. So you can write the Z parameters like this. Z1 plus Z2, Z3. Okay. Then Z12, no, Z12, no, Z3. Okay. Then this one, Z3. Oh, Z3, right? And this one what? Z2 plus
Z3.
Z3. So the first part of the problem, what is that problem? Find Z parameters. So this is the expression for Z parameters. If the circuit has some numerical value, you can calculate this. Suppose Z1 is equal to 2 ohm, Z2 is equal to 3 ohm. So 2 plus 3. So you can, after writing this expression, you can put the value, then you will get the answer. So this is the way to find out Z parameters. So for any circuit, what to do? What is the first step? What to do?
KVL.
Write down two equations, okay? In terms of output, in terms of input. Then after that, if possibility is there, you can simplify it. And these two equations can be related this like this. This is the equation Z11. We have already written in the first phase. Is it same with this? So try to simplify the expression after putting the KVL. So try to simplify the expression in terms of Z11, I1, Z12, I2. Because it is always in matrix form. So Z21, I1, Z22, I2. So this is one way to find out the Z parameters. Again, you can find out different way also. How? Now, put here first condition when what is the first condition?
I2 is 0.
I2 equal to 0. So when I2 is equal to 0, so this part, I2, this part is not there, 0. So Z11 equal to what? From this, we have, what is that? Yes or no?
Yes, ma'am.
So you can find out the parameters by putting those conditions. I2 equal to 0 and I1 is equal to 0. That is the second way to find out this. I think this will be better, this option. No need to put any condition. You can directly write down the expression in matrix notation. Or you can go for this. Same answer you will get. And the second term, again, Z12, what is that? V1 by I2, where? Wrong or what is that? This condition, no, Z22, I think.
Ma'am, Z21.
Z21, yes. 21, V2 by I1. Okay. So that case, Z21. So from which equation we'll get it? Get this answer? From here. Yes or no? So we get Z2 plus what is the answer? 21. When I2 0, so this term will be 0. So we get only Z.
Z3.
So similarly, you can put Z I2 I1 is equal to 0. We will get Z2 to Z1. Okay. Take one simple problem today. Okay. So this is the problem given. R1, R3, R2, this is minus, plus, alpha, R3, I1. Okay, so this is the network. V2, V1, I1, I2. Okay, so find Z parameters. That is the problem for a given network. Find Z parameters of the given network. So tell me V1 equal to what? V1 equal to
I1 R1 plus I2 R.
I1 R1 plus I1 plus I2 R2. Yes or no? Yes.
Yes, ma'am.
Okay. We now simplify this. I1 R2 plus R2 I2. Okay. Now V2 again. V2 equal to next part. What is that? This drop plus R3 I2 plus I1 plus I2 R2. Right? Now you can simplify again. I1 R2 plus alpha R3 plus R2 plus R3 I2. Now, what is your Z11, Z22? So always try to write down Z in matrix form. What is Z11, Z12? You can write that is your answer. Always 2 by 2 matrix. So what is Z11? Tell me first. Z11.
R1 plus R2.
This is your Z11 in terms of I1 Z11. Okay. This is, you can write here R1 plus R2. Then Z12.
R2.
2, yes. Z21. At Z. Okay, so this is the Z parameters. So in this problem, the numerical data, these are not given, not supplied to you. Thus, you can write the expression for Z1. So this Z1 expression, Z parameter expression is different from the previous one. Okay, so for every circuit, you can write down this parameter equation. So try, if there is, say this type of circuits, say 3 loops. Okay, so this is the circuit, say. In this case, what will happen? What to do? What to do in this case? Suppose that case. So this is a network V1, I1. Okay, this is the output I2, V2. So in this case, by using the KVL equation, you will get 3 equation. Yes or no? 3 loop, 3 equation. Say middle one is say this is the first loop, I1. This is the second loop, I2. Say this is the third loop, I3. Kwa buji pasan nai kwa? Not tired? Paisa nai buji kwa? Nai.
Ma'am, I3 part to like I1 or arambho koribo
I1 mo koi asu ya 3 equation hobo. Okay, there will be 3 loop, 3 equation. You can write 3 equations separately. Yes or no? That is already so many problems we have already solved in the second semester. This superposition theorem or current division. You can write this 3 equation, and from the 3 equation, you replace this I3. Try to write down I3 in terms of I1 and I2. If by substitution method or whatever may be the method, you will write down V1 in terms of I1 and I2 only. Similarly, V2 in terms of I1 and I2 only. So by intermediate step, you have to remove this. You have to substitute, replace this I3 in terms of I1 and I2. First, you write down the 3 equation by using the substitution method. Try to find the reduce the expression, simplify the expression in terms of I1 and I2 only. V1 equal to I1 in terms of related to I1 and I2. Similarly, V2, I1 and I2. So for that purpose, so you suppose there are so many resistances are there. Suppose these are say 12. this 2, 3, 4, say 6, 7. So these are the resistances or impedances given in the problem. So you can simplify this. If the numerical values are given to you, so you can simplify adding how, try to find out what is that V1 always in terms of I1 plus in terms of I2. Similarly, V2 in terms of I1 plus in terms of I2. Now, in terms of within bracket, you have to calculate this value. So it completely depends on the circuit parameters given the problem. Okay, so these circuit parameters is different from this, yes or no?
Yes, ma'am.
This is the parameters, okay, all are parameters. But these parameters are known as two-port network Z parameters. But these are the normal parameters of the circuits. It 4 ohm hobo pare, this is maybe 2 ohm, maybe 3 ohm, anything. These are the simple parameters of the circuit. But these are parameters, that is okay. But these are the Z parameters. So every parameter is not the Z parameters. So Z parameters is different from the normal. These are the all parameters. Parameters may be inductive, it may be resistive, capacitive, anything. These are the parameters. But so this chapter is related to two-port network. By any means, you have to replace the whole network in two equations. What is that? V1 and V2. So if you can write down, you can simplify this network in terms of this. You can write this is your Z11. You can calculate. Automatic paribarite. Z12, Z21, Z22. So different circuit has different Z parameters. It's a combination of the parameters in terms of input, in terms of output. So Z parameters is different from the normal. These are the normal parameters. Circuit okay. So you are not asked to calculate branch current in this case. You are not asked to calculate the drop across the 6 ohm resistance. What is the question? Find out Z parameters. So how we can find out Z parameters? By writing the V1 and V2, these two equations in terms of I1 and I2 only. So I3 this is replaced. You have to replace this I3. You have to remove this I3 by this I1 and I2. By using the substitution method, you can do that. So I3, because this is a two pair, it always two-port network, it must be the two-port network. Two-port network has two pairs of terminals, I1 and I2 only, not I3. I3 that 9. Here's two pairs of terminal. What is those terminal? V1 and I1. Input pairs, output pairs, V2 and I2. So every circuit you have to simplify. You have to write down the equation in terms of V1 and I1, V2 and I2. Or the second option, by putting those conditions, you can find out when I2 is equal to 0. So in this case, you can do that. By putting this condition, I think that will be better for this type of, because the circuit has 3 loops. This particular circuit has 3 loops. If you are trying to find out without putting the condition, I think it will be a little bit difficult. So if you go for the condition, it will be easier. If when I2 is equal to 0, this part automatically discarded. Yes or no? When I2, first condition is what is that? When I2 is equal to 0. If you can put this condition, you can remove this part. you will get Z11. You can calculate Z11. So in this type of situation, you can use this condition to find out Z11, Z12, this Z parameters. So two way we can find out Z parameters. One way to put by putting the condition I2 equal to 0 and again I1 is equal to 0. I2 is equal to 0, theta calculate koriba left hand side. When I1 is equal to 0, you can find out this V2 from the right hand side. This is one option, one way to calculate Z parameters. But the second way, try to write down the expression V1 and V2. So what is two-port network? Okay, what is two-port network? Anurag Das. What is
Yes, ma'am.
two-port network? Wow.
Ma'am, a network that consists of two pairs of terminals, where one pair of terminal can be designated as input and another pair being output, is called two-port network.
Two-port network always দুটা terminal থাকিব. Always, that is the two-port. Okay, so a port to ভিতৰত কিবা কিবি আছে. A box to that box. There is a network is here. Okay, so this expression can be written in terms of simply the input pair and the output pair. So tar bhitor kiba kibi ase. So every network has V1 and I1 থাকিবই. Every network has V2 and I2 output. So these two pair can be written, can be simplified in terms of matrix. What is that? Z11, Z12, Z22. This is the matrix. So these parameters is known as Z parameters by impedance matrix. So to find out Z parameters, suppose you are asked to calculate the Z parameters, what to do? First way, two options. Option 1,
Matrix
option 1, yes. Antaripa asan nai? Absent? Antaripa absent?
Yes, ma'am.
Asa, mona mone asa. Huh? What?
Ma'am, she is absent.
She is absent. Okay.
Yes, ma'am.
Then Saurabh Kumar Das. Saurabh. Saurabh. Rodali. What are the two ways to calculate, to find out the Z parameters? What are the two ways?
Ma'am, one is matrix form.
One is matrix form. Suppose you are asked to find out Z parameters. So what to do? First thing. So many times I have repeated this line this way, these options. So this way you joining this class is useless for you. You will be loser, no? Useless, completely useless. How can you manage? By yourself? At the end, just before the exam, what to do? Who can say?
And we use KVL and use the conditions.
By number one, by putting the condition, you can find out Z. Okay. And number two, by writing the two equation, V1 and V2, in terms of what? In terms of I1,
I1
and
and I2.
I2. There is no I3, no question of I3. If your equation consists I3, you have to remove that I3. You have to replace I3 by I1 and I2. So by writing these two equations, you can write down Z11, Z12. So what is Z11, Z12, Z12? So these are the Z parameters. Z parameters of the two-port network. So what we have discussed today, Z parameters. Z parameters, or what is that? Z parameters of two-port network. What is two-port network? The network consists of two pairs of terminals. Very simple. So next class, I will ask you one question. What is the importance? Why the two-port networks exist in the electrical engineering? You search in the net and just tell me the answer. What is the significance of two-port network? That is a very simple question. You can search this in Google. Okay, what is the significance of two-port network? Randomly, I pick up one roll number and you have to ask this, share this answer. Next Friday. Hobo nai?
Yes, ma'am.
Yes, ma'am.
Silo by two. Ki ase two-port to koe aso. So what is the importance of two-port network? Kyo two-port ahile? What is Z parameter? Kyo Z parameter? So next topic, what is that? Y parameters. Same way, Y parameters. Very simple. Just take 5 minutes. Okay, just Z parameters. These are Y parameters. Next, go for Z parameters. This Z parameter. Next is the Y parameters. So what is Y parameters? Same way, the input current and output current can be expressed in terms of this. This is Y. Okay. So this is what? This is what? This is known as Y parameters. So this is the expression for Y parameters. For Y parameters, you have to write down the expression in terms of I. So this is I1, I2. Same way, Y11, Y12, Y21, Y22. That is what? These are the Y parameters. So in this case, again, we have already discussed what is that? P. Z parameters. Okay, this is Z and this is I. This is the expression for Z parameters. So we have Y parameters and Z parameters for two-port network. So for this case, in matrix form, V1, V2, okay, Z11, Z12, Z21, Z22, and this is what? Y1 and Y2. Okay. So to write down the expression in terms of V1 and V2, applied KVL. Yes or no? Kirchhoff voltage law. By applying Kirchhoff voltage law for any network, we can write down the expression for V1 and V2 in terms of I1 and I2. But in this case, what to do? In this case,
Ma'am, in terms of V1 and V2 lage, so KCL.
how we will get this I1 and I2? Kirchhoff current law. Or if you are asked to calculate, say, y parameters, or you calculate z parameters and then go y is equal to z inverse. You will get the answer. That will be better, I think. You calculate z and take the inverse of that. That will give you y parameters. So applying KCL, I think that will be a little bit difficult. So better to use this KVL, find out z, then calculate y, inverse of z. So how to take the inverse? That is the mathematical part. Again, suppose you can calculate y. You want to, from that y, you want to calculate z. Same thing. Z is equal to, yes. So that way, we can find out this y parameters from z parameters. Okay. See? Relation, very important relationship. You write down Z21, Z22. This is what? This is your Z parameters. Okay. So inverse of this is inverse of this. This is equal to what? This Y is determinant of Y matrix. Suppose Y aside, you want to calculate Z. Okay. First, what to do? You find out determinant. Then by dividing this, you will get Z parameters. So how this relation, this derivation is there, that part will be discussed later on. But this is the relationship between Y and Z. So determinant ulab lebo, just divide kori dibo lebo. So be careful. This is Z11, but this is Y22, not Y11. This is Y22, this is Y11. This is minus, this is minus. So for any circuit, suppose calculate Y parameters. Look at the answer. Say. So you can calculate Y parameters directly, or you can calculate Z parameters. After getting that Z parameters, by taking the inverse of that, you will get Y. Etu ki hobo? This is your Y final. Y is Z inverse. So Z inverse is equal to what? This. Okay. So next class I will discuss this Y parameter circuit. Try to solve some problem on how to find out Z parameters, how to find out Y parameters. The given network. Okay. So any question? Any? Kwa? Kiba doubt ase ni kwa? Any bohi asa?
Ma'am, here also if there are like more than 2 loops, we will try to make it 2 variable only.
Okay. I will solve some problems. If there are 3 loops, what to do? Okay. We'll try to solve some problems next class. So in case of 3 loop, anyhow, you replace this I3 in terms of either I2 or I1. There should not be any term related to I3 in the expression. So your Z parameters, these Z parameters of the 2-port network, that is different from the parameters, normal existing parameters of the circuit. So this is the equivalent representation of the network in terms of 2-port. Any question? Hitanse?
No, ma'am. No questions.
কিবা বুজি পাইছানে নে কি এনে বহি আছে ভাগৰ লাগিছে
নাই নাই বুজি পাইছো মেম
হা
বুজি পাইছো মেম
না নিজে নিজে পঢ়িলে বেছি টাইম লাগি যাব ন টাইম লাগি যাব বুক আছে ওকে বুক अवेलेबल আছে you can try but it will take time okay so next class on Friday okay
Ma'am.
yes
Ma'am, Y parameters to ke admittance parameters boli koi nibo?
Admittance parameters. Y parameters is the admittance parameters, Z parameters is the impedance parameters. In short, Z, capital Z likhe. Z parameter, Z dash parameter likhibo, Y dash parameter likhibo. So problem eta dibo, find out Z parameters. So this is what is the relation between Y and Z? Eto belag eta part ase. That is different part. I will discuss later on. But the relationship between Z parameters and Y parameters. So apart from that, some other parameters are also there. Hybrid parameters, Y parameters, Z parameters, so many parameters are there. ABCD parameters. What are the relationship between this ABCD with Z, Z with Y with hybrid? So different relationship for the same problem. Suppose same problem, you can find out Z parameters, Y parameters, hybrid parameters, ABCD parameters. If you know the relationship between these two. Z to from the Z, you can directly find out Y. From the Z, you can, if you know the relationship with the hybrid, you can directly find out the hybrid parameters from the Z itself. Okay. So, wind up here. Good night, everyone.
Thank you, ma'am. Good night.
Thank you, ma'am.
Thank you, ma'am.
Good night.
Okay, and wait, one important thing. So, last group of lab report, you submit the next day, morning. Last one, tomorrow, the last group, D2, I think. D2 or
Ma'am, D1.
D1. Okay. You submit your report the next day, that is 22nd morning. Okay. That's good.
Ma'am, and what about the other groups?
They will come. They will do the experiment, other group. What about the other group? What does it mean?
Oh, ma'am, we have in the afternoon from 11. So,
Huh?
ma'am, we have
11?
from 11. We have to go and do the experiments. When we have to submit the report means.
Every next day, very next day. Today, which group? The last group? D1 or D2? D2.
D2.
D2. Okay, you submit your report next day, tomorrow morning. Then what to do otherwise? For every experiment, you next tomorrow, at what time you will have lab class? Morning or middle slot? Morning slot or middle slot?
Ma'am, morning slot.
Morning slot. So you come in the morning with your report and submit the report with the front of the table and do your experiment. The problem is the last group. With the last group, the last group, what will do? Tomorrow last group is D1. So that group will submit their report in the next day morning slot and wait for some time for correction. Okay? Yes or no?
Okay, ma'am.
Okay, then.